Welcome to the first video of the fourth section, clustering data using the k-means algorithm. In the previous section we saw predictive modelling. In this section we will see clustering of data using k-means algorithm and grouping of data using agglomerative clustering. We'll move on to compress an image using vector quantization, and we'll build mean shift clustering model. Next we will evaluate the performance of clustering algorithms and estimate the number of clusters using the DM-scan algorithm. We'll also learn how to apply these algorithms to stock market data and customer segmentation. Let's start with the first video of this section that deals with using k-means algorithm to divide the data input into k subgroups using various attributes of the data. In this video, we'll first load the input data and then define the number of clusters. Then we will do the initialization of k-means object and finally visualize the boundaries with overlaying centroids. The k-means algorithm is one of the most popular clustering algorithms. This algorithm is used to divide the input data into k subgroups using various attributes of the data. Grouping is achieved using an optimization technique where we try to minimize the sum of squares of distances between the data points and the corresponding centroid of the cluster. If you need a quick refresher, you can learn more about k-means at this webpage. So, now let's see how we can do this in Python. The full code for this video is given in the kmeans.py file already provided to you. Let's look at how it's built. Create a new Python file, and then you need to import these packages into your file. Let's load the input data and define the number of clusters. Here we will use the data multivar text file that's already provided to us. We need to see what the input data looks like. Let's go ahead, and here you can see we have added these lines of code to the Python file. Now let's run the code and see what we get as output. And here we have our output. We're now ready to train the model. Let's initialize the k-means object and train it. So here's the code for it. Now that the data is trained, we move on to visualize the boundaries. So we go ahead and add the code to our Python file. You can see that the step size we have given here is 0.01, and the code to visualize the boundaries is placed just after it. Below you can find the code to predict labels for all our points. We just evaluated the model across a grid of points. Let's now plot these results to view the boundaries. So we do it with these lines of code. And also we have overlaid the centroids on top of it, so you can see both here. Now go to our command prompt and finally run our code. So now we have our output on screen. Fabulous! In this video, we use the k-means algorithm to cluster data. In the next video, we'll compress an image using vector quantization.